So I got asked this Combinatorics question on my Reddit. I got messaged on there. And the message goes as follows: Hello mate, got your video recommended to me. That's always a nice thing to hear. I have a simple PNC, so it's permutations and combinatorics question for you. I had to Google that as well because I'd never heard PNC. In an examination of a mathematics paper, there are 20 questions of equal marks, and to the question paper is divided into 3 sections. So that's section A, B, and C. A student is required to attempt a total of 15 questions, taking at least 4 from each section. If section A has 8 questions, section B has 6 questions, and section C also has 6 questions, then what is the total number of ways that a student can just choose 15 questions? So, I mean, like, they could probably do it in a whole array of ways, but let's stick with the requirements here. So, if we look at what we're asking, so I've kind of just drawn up a picture here real quick, just so that we're all on the same page. So, we've got A, section B, and section C. Now, the thing that's crucial to this question is we're going to be thinking of this thing called the choose function. So what this thing does is, let's say that you have n objects. In this case, we're going to have 8 here, 6 here, and 6 here. But for example, let's look at section B. So I have 6 questions within section B, and let's say that I wanted to pick out just 2 of them. How many different ways is there to do that? So what I'm saying is 6 choose 2, and this is how we write it out. It's kind of a unique function, I guess, and you get this thing. This is supposed to be a 2, not an upside down T, so maybe I should try to fix that. There we go, that's smooth. So the way that this is done, and I'm just going to do it more general here as well. So we have n choose C. So if I have n objects and I want to choose C of them, the formula for this is given as n factorial divided by r factorial times by n minus r factorial. Okay, so now that we've got this idea here, and if I just delete this, let's just, to begin with, let's just calculate how many ways there are to pick 15 questions out of the 20. And so if we plug it into our formula, so we've got 20 questions and we want to pick out 15. So this is without restrictions as well, so we're not worried about having 4 from each section. And what this will do is it'll give us an upper bound. So, and if I just put this in, so this is 15. Actually, I'll do the calculation as well. So that's 20 factorial over 15 factorial times by, and 20 minus 15 is 5. And if you actually calculate this thing, then it should come out as 15,504. So that's how many different ways there are picking 15 questions out of 20. So we should expect a number to be less than this if we restrict it a bit more. So if I just get some room here, get rid of this. Okay. So the first thing that we need to do is we need to find how the workload between the questions is dispersed. And what I mean by that is, so we have to take 4 from each section of the paper. So maybe I can take 7 from A. So we need 15 in total. 7 from A, and let's take 4 questions from B, and let's take 4 questions from C. So that's one way that we could disperse our questions. Another way we could do it is we could take 6 questions from A, 5 questions from B, and 4 questions from C. That's another way to do it. So we need to find a way to keep track of all these things, and I actually just made a list. So this is kind of a brute force approach. And, well, that's not really scaled very well. But, I mean, it's still visible, right? So this is the way that we can distribute all of our questions across all the different sections. And so what we can see here is how we can calculate this. The fundamental thing that the question's asking is, so we're going to have 8 questions and we want to choose 7 of them. So we're going to write that out as 8 choose 7. And then we're going to have 4 questions from B, which is 6 questions, so it's going to be 6 choose 4. I'm going to be multiplying these. And then again for C, it's going to be 6 choose 4. And we need to do this for each different way that we can distribute them. So we're going to add this on to, well, it's going to be 8 choose 6 now. And then we're going to have 6 choose 5. If my pen had allowed me to draw it in correctly. And then 6 choose 4. And we're going to keep going, so on, until we sum over all of these ways we can distribute the questions. And if you do this, and if my calculations are correct, then we should end up with around, well, not around about, we should end up with exactly 11,376 different ways that we can select 15 of these questions, if we have this restriction that we choose at least 4 from each section. And I just wanted to add like a quick note on this channel. I don't have answer sheets for these questions, so if I do get something wrong, please leave it in the comments and I will do a follow-up video and I'll mark in some way that the question needed correcting, or the answer needed correcting. This is just me. I'm just some guy doing this, like, you know. So, well, my dog's barking, so that's probably a good place to stop.